Hey, well, good afternoon, everybody. Lovely to have you joining us today. We've got a action-packed session today. Of course, we're going to talk about the latest building code updates, which were announced yesterday by MB, focusing on making new homes and buildings warmer, drier, and healthier. This obviously means significant changes for manufacturers, suppliers, builders, and homeowners. And MB's comments state that the changes go as far and as fast as is achievable using current insulation products and construction practices, and move us towards the goal of better quality homes and buildings in New Zealand with less impact on the environment. So what do these changes represent? Well, today we have a panel discussion to provide a quick overview of the changes and major implications. So I want to welcome Jason and Robyn, who are with us for the next half an hour or so. If we haven't come across Jason or Robyn before, Jason Quinn is a former NASA rocket scientist who retrained as a building scientist when he moved here in 2009. He's one of our first passive house designers, and in 2016 became the country's first passive house certifier. He's an author, lecturer, and speaker who I'm sure many of you will be familiar with. His business, Sustainable Engineering, specialises in high-performance buildings and provides and reviews passive house design and offer specialist modelling services. And joining Jason, we have Robyn Ryan. Her background's in structural engineering, but her bio states spending time overseas, including studying at Lund University in Sweden. She discovered what warm, dry, and healthy homes are like in Europe. And an interest in passive house design led her to Oculus, where she works on bringing science back into architecture. Oculus use science to design better buildings. Their teams have expertise in the design of windows, walls, doors, roofs, and waterproofing, working closely with architects to deliver weather-tight, cost-effective, energy-efficient, warm, dry homes. All right, well, welcome, Robyn and Jason. Great to have you here with us today.
Thanks, Matt.
Let's just start with a big picture here. Should we be celebrating these changes? Robyn, Jason, what are your thoughts?
Hell yeah.
Go ahead, Jason, you start. All right, I think that it is a step in the right direction, but we've got a long way to go. We've got some more big challenges ahead. So we've got the low-hanging fruit in this update, and then all of the more challenging improvements are coming in the next one.
Yeah, it's well said. I would have liked to seen much more aggressive strategy towards walls, but the reality is that our walls are quite fragile as they are now. So to make a change in H1 without making a change in G4 and E3 at the same time would just be really risky. So
yes.
So although I didn't like to see a small step taken instead of a large step for walls, it was rational.
Yep. So with that in mind, do these changes fundamentally change the way we'll design buildings in the future?
No. Go ahead, Robyn. I know you have a better answer to this than I do.
Yeah, I think it will definitely open up more people's perspective to energy modelling. Accurate energy modelling will become a much more viable option now. If you want to avoid needing, to put ridiculous amounts of insulation in your roof that you can't fit, then you might look at an alternative solution or some energy modelling to solve that problem for you, which is definitely a good thing for the industry.
Yeah, to me, the big change is not in the design of the buildings. I mean, you'll still sort of buy the same kind of products, but for the manufacturing suppliers, what they supply and offer will be quite a bit different, especially in windows, as Robyn and I were talking about yesterday. So there'll be a big change in what's required for windows, and the other systems, slab systems as well, will require quite a bit of changes. But as far as the design of our buildings, unfortunately, they won't require big changes, I guess is what I'll say. I mean, it's great to see a step forward and the buildings will be more energy efficient, but there's still a lot of bigger changes that need to come to really get them the way they should be.
Yes. Yep. Okay. Now I see we've got a few questions in the chat line there. So chat and the Q&A will be open. So at any point you've got any comments or questions for Robyn and Jason, please send those through. So we could see in MB's release that talk about this focus on ensuring dry, healthy and warmer homes. A lot of focus on the warmth, but what about the dryness and health of homes? How is that impacted or reflected in these changes?
Yeah, I think there is mention in the consultation document about the effects that moisture will need to be accounted for with the new changes in insulation, but there's no actual written down methods for people to use to make sure that that's accounted for. So I think what we're seeing is a big, scary statement saying you must make sure you don't cause internal condensation issues, but we need some guidance on how to make sure that doesn't happen.
Yeah, and the reason that's not in there, because it was talked about quite a bit in the consultation behind the scenes as we were going through the technical details, working through this, was that to do that, you really need to get into G4. So other countries require continuous mechanical ventilation in order to control moisture levels and ensure you've got decent ventilation rates, as well as heating, or the ability to heat homes, where we build homes without heating systems in New Zealand, which still shocks my friends back home. And at my home, anyways. But yeah, so it's so some of the the big changes you need to make to buildings to address that statement is not within the H1. I mean, there's pieces you can do, like Robyn would tell you, and I would as well, to make sure you have a really good air control layer at the ceiling line, especially with much thicker insulation to prevent causing additional moisture problems. But that's not in H1's, the ventilation and heating part's not in H1 really. So
yes,
it's unfortunate.
Okay, well, hey, with that in mind, why don't we start looking at some of the changes? And I've got a few slides here that we've just taken from the documentation. I'm sure many of us have seen, but why don't we just quickly look at the continuum time frame, so that I suppose the path that we're actually on, so where this is actually taking us. Jason, do you want to sort of quickly provide an overview of where we've got to and the steps ahead?
Yeah, so this chart looks very much, I suspect, like Brian Berg's carbon continuum from Kaingora, where they talk about taking steps from where we are today in our construction systems all the way through where we need to be in 2050 with a zero carbon society, effectively. The way that NB's label this is they've got this initial release they're putting out now, which is, well, it went into effect yesterday. So now we have a new building code for H1, and we've got a year to basically catch up and meet this building code, which came into effect yesterday. And so that first step they're going to do is to do these changes, and also perhaps some other changes to G4 coming up in less than 12 months. And that's what they call this engage and enable phase. And then at that point, they want to step into building for climate change. And as Robyn pointed out just a moment ago, that maybe we'll want to step up to modeling buildings more, doing predictive thermal modeling. I think she called it accurate thermal modeling, but I'll call it predictive because I like to be risky. So if you can predict the way a building performs on a computer, you can do all kinds of things. So what's going to happen is that we'll transition from what we have now, which is very much the engage and enable phase, where we're increasing our standards, to looking at things in a holistic manner. We actually model the building for operational carbon emissions and embodied carbon in the building. So that's what's in that enable box from 2024 to 2029. And then onwards, from 2030 onwards, the industry will be expected to model all our buildings, which they already do in the UK for operational carbon, and also have some sort of embodied carbon limit in our buildings as well. So those are major changes to the way we design buildings, as well as product suppliers and windows and stuff, right? So most of the folks listening to us, that's the big step that is getting us there.
Yes.
So all of this is just sort of laying the groundwork and taking baby steps along that path.
Gotcha.
Yeah,
Robyn, any comments from you?
Yeah, I'd just like to add, I think it's really good to see this roadmap, because some of the things discussed will be scary to a lot of people out there who haven't needed to account for them in their design today. So, seeing this roadmap, you can see, okay, there's some big changes coming up ahead. We need to all start educating ourselves so that when they come into play, we're well equipped to deal with them.
Robyn, I also think we need to consider the role of manufacturers and suppliers here as well, around what opportunities this presents in terms of bringing new systems, new approach, and new technology into the market here.
Yeah, definitely. So planning the new supply lines and the new products, absolutely, especially with that focus on Windows.
Yes.
Yeah, in the near term, yeah. And then as you go forward, and we start looking at operational carbon, I mean, if you're a supplier and you can pick between two products and one has got 4 or 5 times the embodied carbon in that material, which there are materials that are even worse than that ratio, you can, for a very small cost change, make a significant difference. And right now, there's no advantage to a supplier to make that difference. So they kind of have to do it on their own merit. And maybe they can't even adequately inform the industry to how much better it is. Yeah. Whereas when we've got this built into our modeling tools for the operational energy and the embodied carbon, they can clearly demonstrate the value they're bringing into the industry by changing the way they're doing things, which enables them to sell doing better instead of having to just do better and hope they can make it up somewhere else.
Yes. Yep.
Which many suppliers do.
Jason, you mentioned yesterday about how double glazing was, a big step change that happened a little while ago, but now it's just so common practice. And I think lots of these things will become like that. We'll be looking back in a few years' time thinking, how did we ever do it anyway differently?
Who'd like to quickly cover off our climate zones?
I'll go ahead and do that if you don't. So right now we have 3 climate zones. I mean, everybody knows that. So climate zone 3 is funny. It covers the entire South Island, which means that you're saying that Queenstown is the same as Nelson, right? Which is kind of crazy. So as of yesterday, we have 6 climate zones in our New Zealand building code now. And we have, and you can see them on the map right there. So they're basically designed around the NIWA weather files. So they're no longer so much based upon political division. I mean, obviously they're politically divided, but they're based upon the actual climates in there. And these are very much heating focused. So those climate zone divisions were based upon heating energy for the building, not on moisture levels for doing moisture analysis or for solar radiation, but really were based around heating. So now you have a different climate zone for Queenstown and Nelson, which helps a lot. Unfortunately, this will challenge some suppliers, especially in the South Island, that really want to have one product for the entire South Island. So they'll have to decide how they're going to manage that process, because now you'll have very different installation requirements. Well, you have different installation requirements in Queenstown and Nelson for a good reason, but now you have to supply products that meet that as well.
Cool. Okay. Would you just want to touch on, I suppose, the reference here in terms of the wider building code?
Yeah, sure. We're just talking mainly today about the acceptable solutions highlighted there in green. The changes that were announced yesterday were both verification method and acceptable solution changes. But the alternative solution out there on the left-hand side remains unchanged. So I think BPI of 1.55, Jason, that's still completely unchanged. We're just discussing the acceptable solution as the focus here today.
Yeah, there's a tiny tweak in alternative solutions that enable you to use single zone thermal models instead of multi-zone thermal models, which allows you to use Pascal's planning package for that, so that was done intentionally.
Okay. And then let's start looking at some details. Firstly, let's start with the smaller buildings, that residential focus. A few numbers in here. What stands out to you both?
Yeah, the big one at the top. Yeah, big one at the top is that roof, 6.6 across all the different climate zones. Keep in mind that this is for small residential buildings. Yeah, so that's for all your standalone houses and small buildings. And then the next slide is a little bit more graduated. You see the changes across the different climate zones. But yeah, roof insulation 6.6 across the board. So we're talking between 300 and 500 mils of batt insulation, if that's the way you want to do it, sitting on your ceiling. Yeah, and those, as Jason alluded to before, things like air control and vapor control become really important when you've got less energy moving through that insulation layer. Another big one there in the second line is that walls have almost not changed. They were previously 1.9 in climate zone 1. So yeah, very minor change for the walls, and across the board, it's all remained the same for those reasons Jason outlined earlier. Do you want to talk about that now, Jason, or come back to it a bit further down?
I don't know how much we want to get into it, but in my opinion, and certainly from the testing Brands has done, like actual test building tests, walls in New Zealand are fairly fragile for internal moisture the way we currently run them, with poor ventilation and very little heating. So we have a problem with our 90 mil stud walls are kind of on the borderline as to whether or not they'll have issues from interior moisture, primarily causing condensation at the underlay line on the outside of the walls. So if we just increase the wall thickness without any other changes at the same time, then potentially we could cause more buildings to fail. So not as bad as leaky buildings, don't get me wrong. It's not that bad kind of failure, but it's still horrible, mold. So that's pretty much the reason why the upgrade for walls wasn't done, although there was a strong push to do so, and why it's been held off to be a bit more challenging thing we'll have to deal once we can deal with G4 at the same time as H1. So maybe it's part of building for climate change. As Robyn pointed out, roofs are a big one. The other thing that's interesting is that floors, if you notice, the slab on ground floors are split separately from other floors. And the other floors, like a suspended timber form piles, which is what I love, it's a low embodied carbon floor as well, The R value has gone up quite a bit. The way slab on ground floors R values is calculated is completely different than previous. So you can't use the brand's home insulation guide for calculating what the slab R value is anymore. You have to use the tables that are in the new standard. So the tables are all in their brands recalculated with the new methodology. And the methodology is, anyways, let's just stop there. And the values are, again, were chosen with these R values. We'll get into exactly what they mean later, I hope. But to me, you can't hit those values without edge insulation on a single family detached. And in most of the climates, you'll actually probably need to use some insulation in the slab as well.
Yeah,
so
Jason,
the suppliers now are going to have to go off and sort that.
Good point around sort of the detail. We'll certainly in our summary, we'll have some advice around where more information can be found and what other resources exist. People can get into more detail if and when they'd like to. And
then, Robyn, I know you want to talk about Windows, so we'll let you step down to that one.
Yeah, I think the changes that we see in Windows are going to have a really big effect. That jump from 0.26 to in climate zone 1, 0.46 is going to almost definitely require a change away from non-thermally broken aluminium frames. And we think that it's probably definitely going to need low emissivity coatings on your glass as well to achieve those numbers. There's a little clause, you'll see that the numbers increase a little bit as you go further south to climate zone 6, but there's a little clause in there about a step change for Windows, which will allow window manufacturers to catch up a bit. So I think there's another year, they've got another year before they have to reach the 0.46 in the climate zones 1 and 2. I think, is that in note 2 down the bottom?
Note 3 down the bottom.
Note 3, yep.
Yeah. So the 0.37 will be the first step change, and that will be from November next year. Yeah. Skylights, it's great to see skylights are going to have to improve as well, because there are all manner of issues come from skylights. So that's really good change as well.
Yeah, the interesting about skylights is as you tip double glazing over on its flat, it gets quite a bit lower performance. And the standard referenced in here requires you to calculate that. So, well, the supplier to calculate it and provide it to you. So when you do that, you'll find that it's very difficult to hit these numbers with double glazing and skylights with any sort of New Zealand style frame. So skylights will be a much bigger change in Windows even because of the lower performance when you tip them over, because the convective bubbles get smaller, so the speed increases, so the heat transfer increases as you tip the windows over. But yeah, so it's going to be, Windows is going to be an interesting thing. With very good double glazing, you can hit this in all targets with thermally broken frames. Of course, you could always use New Zealand standard timber joinery is quite good with double glazing as well.
Yeah, or UPVC as well. We'll throw that in as an option. The standards for measuring window and skylight performance, as Jason mentioned, is changed to be the more international recognized ISO standard. So it's similar to when you calculate your windows for passive house. It's the same standard used now.
Yep. Yeah. Hey, so when we think that through, I just want to quickly go back to the roof structure design because we've got some questions coming through here. One of them is, do we still plan to be using our 6.0 bats in the ceiling, or are we actually going towards something else?
Yeah, you're absolutely right. The R value can be achieved in whatever way you like. So, considering a warm roof will probably be a lot easier now as an alternative option. But yeah, I think the typical New Zealand residential house has always been bat insulation, and this R6.6 will start challenging that as a viable solution. There is a kind of leniency around the outside. So where your roof line comes down to meet your wall, that insulation can taper down to
R3.3.
Yeah.
Right. So it's still higher than current.
Yeah.
So that almost always would require to use an energy truss or a raised heel truss, where basically at the outside the top plates of the wall, you just basically, the truss has a little stub plate, so it's just a little bit thicker there to allow you to get the insulation out. So what's implied in here is that the common practice of just leaving a gap all the way around the outside of the roof and having no insulation in the gap is not allowed, is what's implied in here. I still think we'll see inspectors failing to pull up people on the construction side on that, but in theory, you should have R3.3 over the top plates, which would require a raised heel truss. All the truss suppliers you just tell me on a raised heel truss, just tell them how thick you want it. they'll just punch it out in their computer code. It's pretty straightforward. It's not anything new, but you do have to ask for it. At least you do now. Maybe 12 months from now, it'll just be standard. Who knows? 11 months from now, I'm sorry.
You talked about a reference to warm roofs as well. So this, you know, the notion of continuous insulation, which again apply to both roof and also to walls. So obviously that's just a comment here around wall insulation. So this opens up the opportunities for continuous insulation. So insulation that sits beyond the framing.
Yeah, absolutely. You don't have any of the thermal bridging through the framing. So it makes it, you need less to get the same R value essentially. So it's, if you're tight on your, you know, vertical boundary with council requirements, then have a look at a warm roof alternative. It's, you know, often as straightforward as putting your insulation on top of the structure.
Yep. Yeah. And then just another question here: why is there no change in that roof and wall, you know, numbers when you've got such dramatic climatic change across the different regions? What's the logic there?
I'll let that one to you, Jason.
Thanks. I got chucked under the bus on that one. So there's not much logic in it. Let's just go with that. I mean, the R6.6 was chosen. It was a practical consideration, not a logical consideration, considering climate zones. So the idea is that suppliers want to have one solution they want to sell across large swaths of the country in order to solve stocking problems. So the idea was at MB was that if they picked a single R value for at the one point I was looking at it had two different R values across the country, not a single value, then they could solve that. But by the reality is that putting insulation on the roof is inexpensive, even with if you require a raised heel truss, unless you're talking about a warm roof on a height limited site in a commercial zone. And then, you know, increasing warm roof thickness can actually cost a bit of money. But in a typical truss roofed single family detached home, it's quite inexpensive to increase the R value in the roof. So that was the easiest place to change it. And again, with these higher R values, I encourage everyone to be really careful to make sure they have a good air control layer in their ceilings, because as Robyn pointed out just a few minutes ago, you'll have less energy going through that roof. So there's less drying potential going on. So it's more important to keep the warm, moist air inside the building and not in your roof space.
Yes.
Yeah, and they specifically mention around, you know, like light penetrations, mechanical penetrations through your ceiling. Those are the hot spots where we'll get uncontrolled airflow if we don't seal around them.
Yeah, and in the United States, often above bathrooms, because they have can lights, you'll see black mold on the underlay, on the plywood sarking above, because we use plywood sarking everywhere in the United States. Above the bathrooms, you'll see black mold on the inside of the roof, whereas the rest of the roof space will be nice, dry, and healthy. And above the bathrooms, it'll look nasty. It's really common.
I'm just going to jump into a couple of questions here. Will these changes apply to alteration projects?
In the same way they do now. In other words, if you have an alteration, you've got to show that either the alteration meets the new standard by itself, or you've done some kind of combination thing to meet the calculation methodology.
Yep. Question here: will 3604 be updated to include edge insulation details?
I don't know. I hope
there is some talk of changes. But there'll be more standard details. You know, suppliers will put out details that can be used, so you won't be on your own.
Yes. Yep. I can see a few of these others. I could, if I give them to you, Jason, we could be here for quite some time. So why don't we just keep moving?
Why don't we jump to large buildings while you look at those?
Yeah. That's
Yeah.
And then we'll
Thanks for
chat a
keeping
bit
me on
and you
track
pick out your
there.
favorite 10. Yeah.
Yep. Great. Large buildings. Here we go.
Yeah. So I think I'll go first this time, Robyn, and you jump in and we hit walls, all right? So in this one, you can see there is a graduation across roofs. One thing we didn't mention here is that the overall energy savings from the energy modeling that Brands did for MB was something like 40% of single family homes, whereas for large buildings, only about 23%. And that's because as you get a bigger building, there's less envelope to useful floor area inside. So you have less energy savings available to you. So they've ramped up the roof R values all the way from R3.5 in Auckland down to R7, all the way up to R7 in Queenstown. So quite interesting that the range is, it's sort of logical as you look at the climate zones. And then the walls also. So the walls increased in commercial construction because typically commercial construction for large buildings, you have consultants, such as myself or Robyn involved. So, you know, we can handle the fact that you'll need to have mechanical ventilation in your building if you want to do an R3.2 wall. right? Or a dedicated air and vapor control air, one or the other, right? So you've already got that in your team. So that's why MB was willing to change the walls for the commercial buildings. And I guess I'll let you do the bottom half, Robyn.
Yeah, well, I just reinforce that point on ventilation.
Yeah.
These R values are on the basis that mechanical ventilation is going to be there. So the days of using your windows and hoping that the wind blows in the right direction are, in my opinion, over with these walls. You're going to get condensation problems if you don't have proper ventilation. Yeah, and you still might get condensation problems, so we need to be extra careful. Yeah, we've got these stringent window increases here, so they're slightly more relaxed. And I think I saw a note that curtain wall is excluded.
I missed that. Thank you.
Yeah, so that's interesting to note, because a lot of the multi unit residential will have a series of curtain wall in the stairwell or in some part of the project. Like maybe curtain wall's too hard basket for now.
Yeah, I'll have to go look at that, because I was quite excited to see these, because this means to me that commercial buildings now have to be at least double glazed. And to me, especially for shop fronts and shop front automatic doors, because when you try to do higher performance buildings in New Zealand, oftentimes automatic doors are impossible to get double glazed, or very difficult, because everybody else does single glazing. So especially when I ask for triple. So I'll be interested to see what exactly that exclusion for curtain wall is. I missed that in going through this.
A couple of questions have come through. What's the definition here in terms of large buildings between a large residential house and a commercial building?
It's the building use. So if it's going to be used for people's homes, then it's residential.
Yep.
And if it's retail office space, it's commercial building.
Yep. So questions here around where do large homes fit in terms of the scheme?
Oh, so if the home is a mansion over 300 meters squared, you're looking at the table right now. So
yep.
Yeah, I don't think that would be too many people, but
no, Robyn, I don't think that's true. I'm sorry.
Oh, okay.
I have to disagree. I think that if it's housing and buildings under 300 is in the front one, and then this one's large buildings over 300 that are not residential. So, so I think that if you build a 700 square meter mansion, it still has to meet the other table. Much, you don't have our 6.6 roof, right?
Yep.
So if you're building a 600 square meter mansion, 12 months from now, you're going to turn in for building consent, then you need to hit our 6.6 in Auckland.
Yes. And so if we're thinking about aged care as an example, that would be fitting under this the second table, under the large, effectively commercial buildings.
I don't believe so. I believe it's housing, and it's on the first table.
Okay.
So I guess we should hold a lottery on this one, and but yeah, I'm quite certain I wouldn't be saying otherwise.
Yeah.
Yes. Yep.
We've got the MB announcement on Thursday. They're doing a seminar, so I guess questions like that we can pass them on.
Yes. Hey, so a question here, just in terms of timing. Effectively, when do these come into effect and with a particular project? We've got a question here. Do these changes apply to any consents to be lodged starting now?
No. So if you lodge your consent now, it does. You could still do another. You've got your transition period. Mm-hmm. So it's the lodgement of consent. So I imagine that November 2nd, at the end of this next year, will be a lot of consents lodged. Yep. Unfortunately, people doing that are basically cheating their clients, right? I mean, their client may be egging them on to save them money, but these changes save considerable amounts of operational energy, especially in housing. So
yes,
it's a bit of a shame that we'll do that, but I expect we'll see that.
And if you've got a client that is on the fence, have that discussion with them about these changes that you're essentially locking in a change that you can't make in the future. If you've and look at my house here, they replaced the windows about 5 years ago with double glazing, but not thermally broken frames. So now I feel loath to replace those frames because I would be losing another 10 years of life from those window frames. So consider that when you're having those hard chats with your client.
Thinking about those hard chats, what's the impact on housing affordability here? So Jason, your comment around cheating your clients, sort of digesting these changes, what do you see in terms of increased design considerations and costs?
So right now, if you go out and buy the lowest cost double glazed window, and you look at what it would cost the lowest cost single glazed window, the cost difference is not very much. Actually, you don't save all that much money by going from double to single glazing. Whereas in 2008, if you'd done that same cost trade, you would have seen the double glazing cost more than twice as much as the single glazed window in most residential homes. Because we mostly make double glazing now, everybody's set up for it, right? So just the same way here, if you look at the cost difference in manufacturing a window frame with a solid aluminum extrusion versus a thermally broken one, the cost at the manufacturing site where they make the window, like the guy in his garage down the street from your construction site, actually, chop saws the aluminum and screws it together with some gunk and puts the glass in, is actually almost no difference. There is some additional cost at the manufacturing site to make that thermally broken frame, but it's very small at scale. And I expect to see that the difference between, so the cost increase is somewhat artificial at this point because we market those higher performance products for a higher price because they're considered higher performance, right? The cost isn't always real. There's a real cost to the supplier having two different product lines available. So once we take away the lowest performing option, it'll no longer be legal to use them to build homes. Then the cost increase will be smaller. And that's certainly what we see in other countries, in that they can get higher performance products for a much lower cost than we can here in New Zealand because that's the standard product.
It's been talking a lot about the ability to model and the importance there. A question from Glenn: what's the best easily adopted option for energy modeling in-house for an architect? Rather than outsourcing to a specialist, it seems this really needs to be something we can do ourselves and ideally in an efficient way.
Do you want to say it, Robyn, or should I?
I think you should. This is your baby.
Yeah, I think that learning Pass House Planning Package and the Pass House methodology for doing energy modeling is the way to go. If you don't want to step all the way up to using PHP, which can be a bit complicated, although certainly all architects could learn to use it. It's just been designed to be easy to learn. You could learn to use the New Zealand Green Building Council's new Homestar 5 tool called ECO, which I built basically a front end to Pass House Planning Package in Excel, which they've made look beautiful. They looked ugly when I was done, but it's simpler. It's a simpler entry setup for Pass House Planning Package. So it's designed around a similar methodology to the online tool that Brands has available. I forget which one it was. Was it ALF? I think it is. So you go in, you enter your window areas and your wall areas and such, and it calculates a model for you. The difference is, except for shading, the eco tool that Green Building Council has is relatively predictive. So the shading is entered in a relatively crude fashion, but everything else is entered effectively as accurately as you would for Pass House Planning Package. And there's also a three-dimensional interface to it called Design PH, which makes entries fairly easy into Pass House Planning Package. So that's what I'd recommend folks to use. It's simple enough to use on residential projects without breaking a budget, but it's also accurate enough to give the right answers. Other tools I love for like Energy Plus and EcoStar Designer and such are more suited for larger commercial scale buildings. And the real danger is that you get so much data from those tools that you can just spend weeks looking at results, never mind getting the model right. And it's just not really suitable for most of our projects, unfortunately.
Robyn, anything from you on that?
I think just to add Jason's point, Passive House Institute runs a Introduction to Passive House course, which is about a week long. And I would recommend that anyone on this call that's interested or wants to know more should do that course, regardless of whether they're interested in passive house design. It's a really good basic intro to, building science, building physics, and that will equip you with the tools to understand the changes that have occurred now, what you need to be aware of, air tightness, vapor control, thermal bridging. All of those things are covered in a really good 1 week course. I think they do it over 6 weeks in the evenings. It's very easy to do, and it will be a good one, and you'll be essentially a building physicist at the end of it.
In terms of some of the resources we know are available to actually assist with our learning here, because even between us, we've got some questions. I'm just going to put in a link in the chat. It's actually a quick article that we put together on EBOSS with Jason. We've actually got some of your content included in there, and we have a link obviously to information on MB, and there's also a link to the MB webinar, which Robyn, you mentioned 2 o'clock on Thursday, where they're going to spend an hour taking us through, I suppose, more of the details. So some of these questions, it would be great to get in on that call. So in terms of where we've got to, we're celebrating that we've got a change in the right direction. Jason, you've mentioned we're on a pathway towards something big and bold. We're taking small steps to get there. Any sort of final comments around further insights into what people should be looking at, finding more information, or really just their attitude towards sort of embracing these changes? Jason, I'm going to start with you.
Yeah. So their attitudes. So we need to change the way we build buildings in order to change the way they behave. If we're going to actually try to have a zero carbon society, which we need to have, or else people will stop buying our products if you don't have any climate change ambitions, then we need to figure out a way to achieve those zero carbon targets. And buildings are one of the few parts of our society where we can have our cake and eat it too. So if we can build buildings that are very low energy consumption, very low embodied carbon, and they also cost less to own over the lifespan of the building. We're talking 40 years, 100 years, right? So the savings take a long time to accrue. They accrue maybe to society, not to the individual owners, but they do accrue. So that's one part of our economy where we can lower our carbon emissions and get better services for ourselves, right? The rest of the economy, in order to lower our carbon emissions, are going to have to take a reduction in benefit, whether it's less stock on land or some other changes. So this is a very small step, but an important one to help move the whole building industry in that direction, the direction we're all going to have to go.
Yes. Robyn, just before I go to you, there's lots of questions around the software and providing some links. Why don't we just share notes on that, and then as part of sort of the roundup, we'll send out a note to everyone. We'll have those links in there, and also a link to the webinar if people would like to pass that on or rewatch.
Yeah,
so
absolutely.
I hope that's of use.
Yep, we'll do another session in January in the new year when everyone's got all their building consents in before Christmas.
Yep.
So if you need more info, you can keep in touch with Oculus, and we'll do some more lunch and learns. I'm sure, Jason, you'll be running similar things to help people understand the changes. So
yeah,
this is just the announcement, and there's more to come.
Yes. Now, Robyn, I've got some links for everyone here. So if people do want to stay in touch with Oculus, got an email address to subscribe to their updates. You can also follow them on LinkedIn or Instagram as well. And you can find Jason at sustainableengineering.co.nz. Team, thank you so much for joining us today. Great level of enthusiasm and insight. I mean, this really is sort of right at the front of the journey, and really appreciate you guys being able to digest this information so quickly and succinctly relay the key insights to us. So thank you for your efforts there. And for those of you who'd like to join us next week, we have our final Tuesday session. We'll be releasing our construction supply chain data, which we've just released for the Q4 for this year, and I'll be joined by Shane from New Zealand Living. So he wants to talk about how developers are actually delivering projects successfully with the current conditions in terms of labour and supply issues that's been well documented in the media. So that'll be next Tuesday at midday. So until then, all have a fantastic week. Jason and Robyn, thanks again for your time. And everyone else, look out for an email over the next day or so with some links to recording of this and anything else we deem valuable. Thanks very much.
Thank you.
Cheers, team. Bye-bye.
Cheers now. Thank you.